So now I'm going to go over the questions that are in part three of the test review. In this part, we're going to be solving exponential equations with logarithms. So remember, the key here is we want to isolate the exponential term and then use a common log or natural log to go ahead and take that exponent and bring it down in front so that we can then solve for the value of x using our calculator. So let's start off with this problem. We have 13 to the 2x equals 56. So you can see here the exponential term is isolated. So I'm going to go ahead and take the common log of both sides. So I have the log of 13 to the 2x is equal to the log of 56. So remember, we can use that power property to go ahead and bring that 2x down in front. So I have 2x log 13 is equal to the log of 56. So now remember, when I'm solving for x, I'm just going to divide by everything except x, right? So I'm going to divide by 2, I'm going to divide by log 13, and I'm going to do the same thing on both sides. So 2 log 13 over here. And then you can see here what this is going to do is going to cancel everything except for x. So I know that x is equal to the log of 56 divided by 2 log 13. And then I can actually approximate this value using my calculator. So I'm going to go ahead and do log 56 divided by 2 log 13. And we're going to go ahead and round this value that we have. I have 0.7847. Okay, and that is approximately equal to the value of x. So now let's try question two. So here we want to find the value of x, but notice my exponential term is not isolated, right? My 7 to the 2x is the exponential term, but it has that 5 in front. So I'm going to go ahead and start off by dividing both sides by 5. When I do 230 divided by 5, that's going to give me 46. So I have 7 to the 2x is equal to 46. And now that this term is isolated, I can go ahead and take the log of both sides. So I have the log of 7 to the 2x equals the log of 46. So what we're going to do now is use the power property to bring that 2x down in front. So I have 2x log 7 equals log of 46. So I'm going to go ahead and divide both sides now by whatever is going to help me isolate x. So I need to divide by everything but x. So I have 2, and then I have log 7, and I'm going to divide both sides by that 2 log 7. And then here you can see that's going to leave me with just x. So I have x equals log 46 divided by 2 log 7. And I can approximate this value now using my calculator. So I'm going to do log 46 divided by 2 log 7. And so that's going to give me approximately 0.9838. Okay, so now let's try question three. So here we have an exponential equation, but notice that my base of my exponential term is e. So I'm actually going to be using the natural log here, but before I do that, I need to go ahead and isolate that exponential term. The exponential term is not isolated because it has that 4 in front and also I have a minus 10. So remember, I'm going to do the adding and subtracting before I get to the multiplier divide. So I'm going to add 10 to both sides. And so that's going to give me 4e to the x is equal to 54 plus 10, which is 64. Now I'm going to divide both sides by 4. So when I divide both sides by 4, that gives me e to the x is equal to 64 divided by 4, which is 16. Okay, now that e to the x is by itself, I can take the natural log of both sides, right? So I have the natural log of e to the x equals the natural log of 16. Remember, what's going to happen here is when I bring that x down in front, I have x natural log of e, and that natural log of e is just basically 1. So that's going to be x is equal to natural log of 16. I can approximate this now using my calculator. I just go ahead and type ln 16, and that gives me the value, which is 2.7726.